Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are studying about the neutron activation analysis, and in this series of lectures, we have studied about the principle of neutron activation analysis, their processing and instrumentations. And today, I will teach you about the applications of neutron activation analysis. As you know, there are so many techniques that are being used for the determination of elements in a sample material. But in case of neutron activation analysis, that is a unique technique with respect to the use of radioactive material, and a sample is activated using some sort of a massive particle like that, a neutron, and we get excited and sample material having the ability to liberate radiations, most probably the gamma radiations. The measurement of gamma radiation gave us information about the sample, what type of elements are there and in what quantities. So most elements have been determined by activation analysis using thermal or fast neutron. In view of this effect, the existence of a large number of papers concerning activation analysis of different elements in various matrix. So bibliography is at the end of this lecture, and the review article that have been published recently and previously give us a lot of information about the activation analysis procedure and will help in uh, solving the problems regarding the determination of elements that appearing in order to uh, measure some sort of in order to determine some sort of elements in a sample material. So all these play very important role. So a chemist may take help from these review articles and bibliographies. Other thing is that there is a monogram that have been published by IAEA, International Atomic Energy Agency. This is also very important a monogram that play having a lot of applications of the neutron activation analysis for information, and in order to get more and more knowledge, you may also consult this monogram as well. Okay. If we see about the activation analysis, there is a direct gamma ray spectrometry or on irradiated sample is the preferred counting technique owing to the speed and freedom from separation and subsequent losses of material. Definitely, the most important thing is that when a sample is being activated in a nuclear reactor, after that the gamma radiations are being emitted, and that gamma radiation that we measured, and for the measurement of for the determination of different kind of elements in order, irrespective of the fact that someone want to use some other technique for the subsequent separation and like that, which have associated with loss of material and some other issues. So most of the scientists and chemists preferably prefer to count directly gamma radiation in order to measure the different kind of elements in a sample material. So various type of neutron sources are used to acquaint the reader with their application. Definitely, it is not only the single source of neutron activation, neutron, but there are so many neutrons sources that produce neutron. As you have studied, there are mainly three neutron sources you have studied previously. So although a certain type of neutron sources is used in a particular cases, other type of sources may be equally satisfactory. In information concerning the neutron flux from various sources is given in chapter 2 of this monogram that is being I have shared with you last previous lectures. In that there is a chapter 2 that give a lot of information about the different neutron fluxes, and you may choose according to your own need. The neutron dosage depends on available flux spectrum, sample size, half-life of a product, and desired sensitivity. So these are the main criteria on which a neutron source is being selected. In an effort to provide information to analytical chemists working in a wide field of endeavor, examples of activation analysis have been selected from archaeology, biology, chemical and metallurgical industries, criminology, crops and food, geochemistry, petroleum industry, semiconductor and space explorations. So these are the some exemplary fields in which neutron activation analysis is being used. But there are the area of the application of neutron activation analysis is very vast, and you can use anywhere of in which you would like to determine the element. So we can not limited the application of neutron activation as just the writing fields as I have mentioned here. So there are the scope of the neutron activation analysis is beyond these fields as well. Okay. So this is a general procedure. What is the general procedure of neutron activation analysis? You should know there is a main three. First of all, you have to collect the sample material. You will receive the sample material which you would like to determine the element as like that. So definitely, first of all, you have to treat pre-irradiation. Pre-irradiation mean you should have to clean it. You should have to make it ready for the radiation processes. In this process, pre-irradiation actually um, consists of two main things. One thing is that to clean it, clean from dust and like that other impurities, that is almost physical cleaning. And the second step in pre-irradiation step is that you should have to uh, encapsulate it in some material like that aluminum and other in order to save it in a particular type of a vial, so for irradiation process. So this is a pre-irradiation. The second, after when you completed your pre-irradiation process, you should have to irradiate. So irradiation, I mean, now you have putting the material into a nuclear reactor for the irradiation in order to explore your material for neutron flux. And this is a actual theme process and a core process of activation analysis, because you are going to irradiate it with the help of neutron flux. Particular type of flux is being used, and there is a, as you studied and you read in previous slide, there is not only one kind of uh, you can say that flux, neutron flux, but there are various and range of fluxes available depending on your sample material, depending on your requirement, what type of determination you would like to complete through this process. So for example, if there is a sample material having an element required only a very mild range of flux, and you give it very high range of flux material, so it is somewhat may create abnormality in this process. So you should have to take care about the compatibility between the sample material as well as the neutron flux. So this is very carefully adjusted. So the next process is that after irradiation, because your sample now activated, and after activation, there is a post irradiation process. And what is meant by post irradiation process? When your sample is got irradiation and it will now become activated, so you should have to treat it either as different type of treatment maybe there, like that chemical separation, like that physical separation. And similarly you should have sometime it is possible you would like to determine, you would like to measure only one kind of element, then but definitely you should have to separate it from the rest of the material. So in this particular aspect, you should have to take the help from chemical separation process, and definitely this chemical separation process will help you in order to get your particular type of element. So this is called post irradiation process. In other words, you may also use this process irradiation, a post irradiation process, that is mainly consist of chemical separation. and definitely if you would like to separate more than one element in order to measure separately, so this process is also very important, but one should be carefully about in this process, because it is during this process exposure to the radiation is very high. So this is somewhat tricky and somewhat you can say that exposing a process to radiation, so care must be done during this process. So this is the main general procedure about the activation analysis for the applications of sample material. First of all, pre-irradiation, then irradiation, and then post-irradiation. And so this is you should know about that. This is a cyclotron, that is the main source of neutron production. So this is you can say that this is a view of the U-120 um, mega cyclotron. So this is a 10 and this one A, and B is sorry, overall this is a cyclotron, and this is a tentron B, and this is a microtron, and they actually processing the flux of the neutron. And this is and the research reactor, and this is a research reactor where the sample is kept, and through these two materials and instrumentations, a neutron is being bombarded the sample that we put in this nuclear reactor. So this is a general view about just for your information. uh, so in this process, this is all concerned about the irradiation process, irradiation. So now we come to the applications of neutron activation analysis. There are, there are two type of neutron activation. One is thermal neutron activation, and other is fast neutron activation. So we would like to share with you some information about the thermal neutron activation analysis in the field of archaeology. The non-destructive activation analysis of ancient silver coins from the 5th century before Christ has been reported by Atkin. Okay, such analysis in archaeology provided information about the origin of material and on the technology and economics of the era. In the case reported here, evidence was obtained from of the uh, debasement of coin. Following is the method implied by these authors. So it is very important that any ancient thing that you find from archaeology, from any way, uh, that may be from earth and some other kind of sources. So the important thing is that to analyze what type of elements are there, and from these elements you may also take the information what type of the minds of the people living in that era, what type of element they are focusing by these peoples. So this is a lot of information you can get from one thing that is belong to that era. So this is the very kind information, that is a kind application in neutron activation analysis regarding the uh, analysis of coins and like that substances that is very old and antique. So what should be the procedure in order to activate, in order to determine the elemental composition of these coins? So there is a procedure: element determine copper, silver, and gold. So one thing it should be in your mind sometime you are thinking about that the old people, these kings and like that, use to gold only in their utensils, and but you should know that there is a some sort of you can say that not mixing of copper, silver as well in these materials. So pre-irradiation treatment is that place the coin weighing from 1 to 17 gram and standard in irradiation cane. Okay, so this is you can say that pre-irradiation process. there is no radiation, there is just you are preparing your sample material in order to irradiate it. So you should have to weighing about 1 to 17 gram and standards in irradiation gain. What is irradiation? Irradiation can in the reactor with the thermal flux to a doses of about 3 into 10 raised per 30 neutron per centimeter square. So this is irradiation process. So I think in irradiation process you should only concerned about what type of flux of neutron you are being used. So the next thing is that post irradiation process. In post-irradiation treatment, obtain the gamma spectra of coin and standard using a gamma scintillation spectrometer. Determine the area under the following photopeaks. So in post irradiation treatment, there are two main sections. One is section is that if you would like to separate the material that is you are being want to determine, so you should have to chemically separate it. And other is after separation, or if you if you don't like to separate, then you directly come to the measurement of gamma rays, and you will get the gamma spectrogram. So definitely that will give you some peaks, and from that peaks you will compare it with some sort of standard peaks, and you would be able to calculate qualitatively as well as quantitatively. So in post irradiation process, there is an also the analysis of the material. So when you analyze the gamma scintillation spectrometry, and you will find three main peaks. One is at a 0.511 mega electron volt positron annihilation process. It that actually obtained through positron annihilation process. Other is 0.884 mega electron volt gamma ray, and third one is 0.41 mega electron volt gamma ray. So these three peaks concerned about the copper, silver, and gold. So make corrections for the com Compton spectra from other photo peaks when determining area under peaks. So definitely when you are going to determine the peaks under the area sorry under the peaks, definitely you should have to take care about the Compton spectra as well. That is there is a associated spectra. So that is the important thing is that this is the analysis that would not be able to carry out with the help of other kind of uh, instrument, but in neutron activation analysis we would be able to do this job very easily. At the note, the gold content range from 0.02 to 0.3%, and the copper content range from 0.1 to 10%. So this is also the quantitative information about this application. Okay. Other is biological material. A number of analyses are presented involved determination of elements in biological and plant material. So definitely there are so many biological material that actually these biological material may be associated with a very old era and the previous past era. So definitely you should also have to take information about what type of elements are present in that biological materials, and definitely that will give you information about the uses of the material by that biological living organisms or things. Elements determine phosphorus in beetle wings. So this is a very tricky and very difficult to determine with the help of common instrumentation. Determination phosphorus in beetle wing, because this is a sample issue. So due to this reason, but in this case of neutron activation analysis, this process is very quickly, and we will be able to do it very um, excellently. So what is the pre-irradiation treatment? Definitely it is a preparation of the sample for the irradiation process. So pack the beetle wings and the standard of potassium biphosphate in polyethylene envelope, and sandwich the envelope between aluminum foils to reduce radiation damage to wings and envelopes. Seal the envelope and foil into an aluminum irradiation can. So definitely, dear students, this is an example, but you should take care and you should apply it on other veins as well. Some, if you would like to analyze some sort of veins of different animals, so definitely like that insects. So definitely you should have to prepare your sample like that, prepared here. Uh, First of all, you have to seal in polyethylene along with the sample material along with standard material, and then sandwich it between the two aluminum files to reduce the radiation damage, and then you should have to irradiate it. So in irradiation process, this is only what type of flux and how many times the neutron bombardment is required in this process. So if we see here, there is a irradiation cane for 8 hours in thermal flux of 5 into 10 raised by 12 neutron per centimeter square per second. So this is a neutron flux for 8 hours. So this is required in order to determine the veins, in order to determine the elements like their phosphorus and vitamins. So this type of flux is required. So what is the post-irradiation treatment? Attach each wing with a double-faced tape to a polyethylene sample holder. Prepare a similar standard by dissolving irradiation potassium biphosphate standard material and evaporating aliquots containing 0.28 microgram of phosphorus on sample holders. Place the sample and standard under an end window gigamolar counter and observe decay of the activity for about 1 month. Monitor the stability of a counter each time with the strontium yttrium source. Observe a 14 days half-life of the decay after potassium 42 and sodium 24 have decayed. So this is there is two other sources as well there, because one is potassium and might be there is sodium as well. So first of all, you should have to take the peak of about 14 days half-life peak that will appear later on after potassium and sodium. So this is a post irradiation process that is required, that is should take care in different kind of materials that varies from sample to sample, that is not associated, that is not a journal. And so this is a specific treatment uh, regarding the sample material. If there is a coins, there is some sort of a different post irradiation process. If there is a beetle wings and another sample, so it will be different from already mentioned. So an average of phosphorus content of about 0.03 microgram per wings was determined in this process. Okay, so these are some other applications belonging to element determined cobalt and tissues in the biological material. So this is a simple tissue, that is you should have any type of biological tissue. Heat seal a tissue specimen into polyethylene envelope and then wrap gold flux monitoring files in polyethylene envelope and place specimen and files in irradiation cane. So this is a very simple pre-irradiation treatment. And irradiation required how many times, how much times you have to bombard it with the neutron, and what type of flux you should have to use for this irradiation and activation process. So irradiate the coin in thermal flux of 1 into 10 raised per 12 neutron per centimeter square per second for 30 minutes, and transfer the cane to laboratory using a rapid transfer device, because it should be in your mind, this is as you know, this is a very simple and small time is required. So as small time is required for irradiation, so transfer is also should be very quickly, because decay process very quickly here. So in order to measure good and right analytical processes and concentration of cobalt in a tissue, you should have to transfer it very rapidly to the laboratory for further analysis. Post-irradiation treatment. In this post-irradiation treatment, place a known amount of cobalt tracers and 10 milligram of cobalt carrier solution in a nickel crucible. Add 3 sodium hydroxide pellets to the crucible and heat the solution to near dryness. Just prior to receipt of the irradiation system, a specimen, add 10 gram of sodium oxide to the crucible and melt. So it should be in your mind all the processes that is place a known amount of cobalt of and 10 milligram of cobalt carrier solution like that. You should have to prepare already when you are just know about that. After some time we will receive this irradiated specimen. So before reaching the irradiated specimen to the laboratory, all these things should be prepared, and it is very important in order to do some experimental work. The homework should be very strong and before starting the material, before starting the analysis. So in this regard, when a irradiation specimen reached at 10 gram of sodium oxide just prior to the recipient of the irradiated specimen, okay, and 10 gram of sodium oxide to the crucible and melt. Add the specimen to the melt and fuse the material for 1 minute, keeping a cover on the crucible. Then dip the crucible into a beaker of cold water to cool its contents. Dissolve the melt by addition of 50 ml of water. Use a liquid nitrogen to accelerate cooling to room temperature. Slowly add 20 ml of glacial acetic acid to the solution and cool to room temperature with liquid nitrogen. Transfer the mixture pH of 5 to 6 to a 150 ml separatory funnel containing 25 ml of 8-hydroxyquinoline solution 3% in chloroform and shake funnel for 1 minute. Back to the extract cobalt into the aqueous phase by shaking with 10 ml of 9 molar HCl. Okay, so this is a stepwise addition of different materials in order to reach at your goal. Add sodium oxide to the HCl solution to precipitate the oxide. Then collect the precipitate on a filter chimney, wash with water, and place the prepared counting specimen in the gamma ray spectrometer. So this is the preparation for the sample material to determine the gamma radiation. Obtain specimen at point to point 0 to 0.25 and 0 to 2 mega electron volt, and determine there are under area under the 0.059 a mega electron volt peak, that is a cobalt peak. So this is a specific for cobalt, and each peak is unique in gamma ray spectroscopy. It should be in your mind that each type of peak is concerned with a specific element. Use the 1.17 and 1.33 mega electron peak of the added cobalt to determine the chemical yield. Correct the cobalt data for the chemical yield. Count the 0.41 mega electron volt photo peak from the gold file on the gamma spectrometer to determine the neutron doses and neutralize the cobalt data to a flux of 1 into 10 raised by 12 neutron per centimeter square per second. This is a flux that actually you have used in the neutron activation analysis process for radiation. Okay, standard cobalt activation was run previously. Okay, calculate the cobalt contents of the specimen. So at the end, what actually we obtain after irradiation in a thermal flux of about 1 into 10 raised by 12 neutron per centimeter square per second, and 15-minute radiochemical separation with 40% chemical yield. Low limit of 5 into 10 to the minus 8 gram of cobalt was obtained. So this is a very good data at very low limit in the range of the nanogram, one can determine with the help of these analytical techniques. So other is the molybdenum in plant material. So this is also a determination of element in a biological material. So dear students, this is again because it is also a biological material and you would like to determine molybdenum. So there is also three processes. One is pre-irradiation, irradiation, and post-irradiation. So in this sample material, you should have to place a sample material of about 0.5 gram of clover and 4 microgram molybdenum standard in quartz in a flexiglass can. So this is a different kind of sample. You can say that sample holders that you are using in order to irradiate. So irradiation is about 1.4 into 10 raised to 12 neutron per centimeter square per second for molybdenum 101 for 5 hours. It is this is a process, and in post irradiation process there is some sort of a radiochemical separation and then analysis of the material. So analyze the solution by placing them in a bottle in a well of 3 inch into 3 inch sodium iodide. This sodium iodide doped with thallium crystal, this is a scintillation detector that actually receive the radiation from sample material that you are using, you are going to determine. So this scintillation trigger the photo cells for the production of more and more neutral electrons and electrical peaks, electrical current that give you information about the sample material that is being radiated and activated. Okay, so gamma spectra is obtained. Molybdenum 101 is analyzed by its 0.191 mega electron volt peak, and molybdenum by its 0.140 mega electron volt peak. So these are the two peaks that is we obtain in a sample material, and due to this we would be able to calculate its quantity as well. The molybdenum contents of log was determined as 1 ppm. The time for the complete analysis, including 20-minute irradiation, was 72 minutes. Today, we definitely take some, you can say that, other way about the applications. So I think at this moment you should have to study these applications carefully, and we see again inshallah in next lecture for further applications. See you again inshallah. Allah Hafiz.